I'm Justine Murphy with Laser Focus World. Let's take a look at some of the amazing things happening in photonics. Organic LEDs, or OLEDs, are standard in smartphone screens and televisions, wearable devices, and vehicles. And now the technology is adding wireless communications and a potential to revolutionize device connectivity to its repertoire. A team of researchers from the University of St. Andrews in Scotland and the University of Cambridge in the UK have designed OLEDs that can transmit data over what they say are record-breaking speeds and distances. OLEDs have long shown potential for visible light communication systems, also called Li-Fi. They're thin, flexible, and easy to make. However, they've traditionally been too slow for high-speed data transmission. Based on dinaphthylparaline, a fluorescent emitter material known for its stability and fast radiative emission, the team says their design is faster, brighter, and reduces the OLED's charge transit times while maintaining high optical output. In a series of tests, the new technology demonstrated data transmission at 4 gigabits per second over a 2-meter free space link, and 2.9 gigabits per second over 10 meters, which the team says is 40 times farther than previous OLED-based transmission. Ultimately, the new OLEDs could turn conventional display technology into secure, high-speed wireless data transmitters. OpenLight Photonics, a California-based developer of photonic application-specific integrated circuit design tools, has secured $34 million in Series A funding. Company representatives say this step allows OpenLight to transition from a subsidiary of Synopsys, which created it in collaboration with Juniper Networks, to its own venture-backed company. The funding award will be used to boost OpenLight's reference designs for devices needed for optical interconnects in AI data center links. In other business news, Photonic, a quantum computing and networking company based in Canada, has received a $1 million CAD grant after being named a semi-finalist in the Canadian Department of National Defence's Innovation for Defense Excellence and Security NORAD Modernization Science and Technology Contest for its advancement of quantum repeater and networking technologies. Company officials say these technologies are a key step toward next-generation quantum sensing and communication systems. A collaborative team of scientists is now exploring the limits of solid-state matter, disproving a decades-old theory. The team from the U.S. Department of Energy's SLAC National Accelerator Lab and the University of Nevada, Reno have been able to superheat gold at more than 14 times its melting point using SLAC's LINAC coherent light source, the world's most powerful X-ray laser. This upends the long-believed theory of entropy catastrophe, the team says, which states solids can't remain stable at more than 3 times their melting temperature without melting, and that a solid becomes more disordered than its liquid counterpart. The new approach involves detecting tiny changes in the way X-rays scatter off atoms in a material via the free electron LCLS. In this work, the team heated a 50 nanometer thick gold foil using a frequency-doubled titanium sapphire laser that produced 400 nanometer wavelength pulses. Only about 0.3 microjoules of energy were used per pulse to create the superheated gold, which the team says, in principle, could be reproduced in other laser labs. The team says their approach lays a path for benchmarking equations of state, validating hydrodynamic simulations, and exploring matter in systems that were not previously possible. And that's your Photonics Hot List. Be sure to like and share, subscribe to our YouTube channel, follow us on social media, and visit laserfocusworld.com for the latest and coolest news and information. Check out our Following the Photons podcast, too, for some cool interviews and news impacting the industry. Until next time.